we'll be talking about the physics of flying an airplane. Today's topic will be covering Bernoulli's principle as it applies to pressure and lift and the forces that act on an airplane, and each subcategory of forces. Firstly, Bernoulli's principle. We all know it to be for fluid, but it also can be considered for air, or air can also be considered a fluid in this case. Bernoulli's principle says that faster moving fluid has lower pressure and slower moving liquid has higher pressure. The shape of the wings on all aircraft make the top surface area longer and the underside smaller. This is because of the eyebrow-like shape, as shown here. This is the cross-section of an airplane wing. When the air flows over the wings, it has to go faster over the top and slower over the bottom to keep the flow rate the same. So the air going over this distance has to go faster than this air, because this area is larger than this area. Because there's slower moving fluids, there's higher pressure, and because there's faster moving fluid over here, there's lower pressure. And this creates pressure and lift that lifts the airplane up. This is the thing that is most responsible for flight, and essentially is what makes planes fly. Talking about lift, the forces that act on the airplane are very simple. Lift applies straight up force. Gravity supplies straight down force from the center of gravity, which can be moved in accordance to how the bags are stacked compared to the arm, which is the distance from the firewall back, measured in inches or feet. Thrust pulls the airplane forward, and drag pulls the airplane backwards. These are the four forces that act on an airplane. This is a little bit different from AP Physics 1 because you can usually examine Fy or Fx and look at them separately. However, the forces that act on an airplane all work together. We'll see this more when we look at lift and drag. The most important concept is when all the forces are equilibrium, or all the sum of the forces is equal to 0, the plane is in straight, coordinated, unaccelerated flight, and this is the key to flying. Thrust is the force supplied by the propeller. This can also be applied to Bernoulli's law. The shape of the propeller is similar to the shape of the wing. The cross-section looks like this. Not only does this create low pressure and fast-moving velocity of the air pulling the airplane forward, that creates thrust. So here you have a high pressure and here you have a low pressure, which pulls the airplane forward. That's because here there's faster moving fluid or air, and here there's slower. This also helps create thrust. And thirdly, the air that's moving faster behind the propeller goes over the wings and creates more lift that way. Lift is pretty much Bernoulli's principle as we talked about. The lift equation is L equals 1/2 density of the air, velocity squared, coefficient of lift times surface area of the wings. This right here looks almost identical to the kinetic Bernoulli's equation. The only difference that we see is the surface area and the coefficient of lift, which are unique to each aircraft. Density also plays a major role in aviation, specifically the density of the air. There is, as you see here, a proportional relationship between the amount of lift that an airplane creates and the density of the air, meaning that as density of the air increases, lift will also increase. Density in the air is the amount of compaction that the local air expenses Factors that influence this are winds, temperatures, and incoming storms, all of which amount to temperature fluctuation. When the outside air is more hot, it is more expanded, whereas when it is more cold, it is more contracted. Changing the density of the air ultimately means that changing the temperature can also change the amount of lift that an airplane experiences. This is proven because air density is proportional to lift. Another way to look at this is that the air going between the wings is more compacted and there's more air molecules that have to travel faster to meet at this point to keep the flow rate the same. And then thirdly, the last thing that density can help planes fly better is that there's more molecules, air molecules per amount of air, and the engine will be able to take in more air and make more power. Similar to Bernoulli's principle, turning works the same way. On the outboards of the wings, there are ailerons which are controlled by the yoke in the cockpit. This works by extending the surface area on one side. So if this was our regular wing, then when we extend our aileron, it would look a little bit more elongated. So this means that this, in theory, would be shorter and this would be longer, meaning that this has to go faster and this has to go slower. This means that there would be more pressure here and lower pressure here. On the other side, the ailerons work in opposite ways. So on the other side, the angle here would be shorter, and that means that there would be less lift on that side, creating more pressure and suction on either side. And this ultimately causes the plane to turn. One of the most important parts of aviation is being able to land, and it wouldn't be possible without flaps. Flaps are similar to ailerons, however, they're on the inboards of the wings. Flaps slow you down because you need to slow down to descend and to land. Therefore, you need a steady descent angle, but too steep is too fast, and too slow you won't descend enough because of the way that lift and drag interact with each other. Flaps fix this problem. You can extend them with a lever of increments of 10 degrees, 20 degrees, 30 degrees, and some models even have 40. The first 10 degrees of flaps increase the surface area and create more lift than drag, which is unhandy. If airspeed increases, then you would lose altitude. This is because you would trade your gravitational energy for kinetic energy. This is an example of how lift interacts with drag. The first 10 degrees also slow the aircraft down but produces lift because thrust is traded for lift. This is important because the aircraft maintains the same energy but traded gravitational for kinetic. The rest of the flaps create more drag so that the aircraft has a steady descent angle that is larger without having to increase the airspeed. The last force that we're going to be talking about is drag. It's very simple. There's parasitic drag and induced drag. Parasitic drag is caused by things like antennas, open windows, ports, and wheels. Think a parasite on a plane. Induced drag is made from things that are needed for the aircraft to create lift, like wings, air resistance, friction, and the cockpit. As speed and thrust increase, parasite drag decreases. So as thrust increase, induced drag increases. And it looks something like this. And as speed increases, parasitic drag decreases. And this is like your overall drag. So that just shows you a little bit of a relationship. The drag equation is very similar to the lift equation, where drag equals 1/2 density air velocity squared, coefficient of drag times the surface area, where this and this is all the same. However, the coefficient of drag is the coefficient of lift plus a constant, which is unique to the aircraft, times the coefficient of drag. And each one of these things is unique. That's all about drag. Turning an airplane is not that complex, as well as all the other forces that we have talked about. G-force is the same. When you turn an aircraft, the lift acts horizontally or in an angle that is similar to the angle that the airplane is turning, but gravity still works downwards. These are equal to what they are when the airplane is straight and unaccelerated. However, the vertical component of lift is not equal to the vertical component of gravity. So, the pilot must apply a back pressure to the yoke, making the airplane maintain altitude and lose a little bit of airspeed so that it doesn't descend. This makes lift. This makes lift, and that lift that it makes is proportional to this horizontal component of lift, which is also proportional to the G-force that you would experience in a plane. Yeah. Because you have to make up for this component of lift that is missing. So you have to apply this much pressure, which you would feel the gravity acting against you because it's the way that the plane wants to accelerate, but you're accelerating upwards. Okay, moving on. Typically when a plane is flying, or ground effect is a phenomenon that occurs when the plane is the wingspan length over the ground. For example, if this was length 30 feet, when it is 30 feet over the ground, say this is your plane, this is where ground effect would happen. Because the wings produce lift, we know that there's a pressure difference between under and on top of the wings. Physics tells us that the high pressure air wants to go to the low pressure area to create an equilibrium. Throughout the entire flight, the ends of the wings have air that comes over the top to fill in this low pressure area and make an equilibrium from this high pressure area. So there's constant air that goes around this. This is what causes wake turbulence, because this is part of your total wake. When close to the ground, the vortices, which are these, start hitting the ground. And create partial lift. This, in theory, lifts the plane up out of ground effect in some cases and loses kinetic energy and trades that for gravitational potential. Now it has little speed and goes back down into ground effect. This creates a purposing effect of going up and down and up and down and up and down. Realistically, you can only do this about 3 times. And this is really dangerous in small planes because you can hit the front propeller, which is already dangerously close to the ground. This creates a lot of damage and inevitably will create a larger accident. To avoid this, pilots will pitch down when entering in ground effect to gain airspeed from the lift instead of lifting out of ground effect. However, this is an extremely difficult maneuver because you must pitch down a decent amount and it can look like you're diving for the ground. This can be extremely scary and non-intuitive. And lastly, for a very short topic, is how planes fly upside down. You might have seen this in acrobatic flying or anything like that. This is because the wing shape of these planes is just straight, and they're able to bend this down or up depending on which side they want to create lift. So for example, if we're looking at this one, the lift would be acting this way, whereas if you're looking at this one, the lift will be acting this way. So they can change the way that the lift acts in reference to the plane, up or down. And yeah, that's all that I have to share. So thanks for listening.